Okay, we are going to go over a word problem that you would encounter while solving questions in standard form or vertex form. It could come up in either part, but it is essentially modeling a real life problem using quadratics. Okay, so we're going to have a farmer because this is a stereotypical problem you'll encounter, but it's an area and length problem or an area perimeter problem. So we'll say that there is a farmer and he has 100 meters of fencing and he wants to build a corral, but he wants to make it the biggest corral. So that he wants to make the area maximum. So we're going to use this. It should also be a square, like area max rectangle. So what we have here is we know that the perimeter of a rectangle is the width and the length. So we know that it's 2 widths plus 2 lengths is our perimeter. But we know the area for this is also just the width times the length. Now, we know how much fence we have. We have 100 meters of fence to go all the way around. So we put 100 in here. And we can factor the 2 out. So we have a 2 times W plus L. And let's divide by 2. And we find that 50 equals W plus L. We want to isolate one of these variables. So let's just solve for W. Let's just say W equals 50. And we're going to subtract L from both sides. So we have minus L. So now we have an equation that defines the width in terms of the length. So we can go to our area and we can say, well, W is just 50 minus L. And then we have times L. Well, this kind of looks like a quadratic now in standard form. It just doesn't have a c. So if we had the function of x is ax squared plus bx plus c, this is the exact same except a is -1, b is 50, and c is 0. So we know how to find the x component of our vertex. So we just take a, so it's negative b over 2a. So we have negative b, which is minus 50, over 2 times a, which is -1. And that just equals half of that is 25, and the negatives cancel out, so 25. So we know that the vertex is now going to be happening at 25. So why don't we find what our y value is for the vertex, and we substitute that back into our area function. So area equals 50 times 25. So let's say this is our L. We solve for L in this. And this is 25 squared. So this will be 1250 minus 625, which is 625. And because it's an area, This is meters squared. Now we can just graph this really quick. So this is our area, and this is our length. We know that when it is 25, the area is 625. And we know that if the length is 0, the area is 0. And if the length is 50, we know that the area is 50. So the parabola goes like this. And our vertex here is 25, 625. Kind of ran out of room there. But that's what we're trying to solve. We can also write the domain and range. So if we want the domain, it is the L such that the length is an element of a real number, but the length has to be between 0 and 50. I really ran out of room on this. And now the range, this is the problem with writing in Sharpie, is our area. And it's the area is an element of a real number. But the area also has to go from 0 to 620, so 625. And that is how you're going to do a word problem or model various types of word problems you'll encounter in quadratics.